Okay, here we go. We've got a photoelectric effect question. I've noticed a few ones like this, so absolutely take the time, HL students, to have a look at this. SL, get out of here. You don't need to worry about this one. When you're ready to see an explanation, hit play. Okay, so as I've said, this is definitely a common question in IB physics and in A-level indeed as well. It's a really common one where we look at graphs and we're trying to understand the graphs that come from the photoelectric effect. So let's talk about the photoelectric effect. Okay, hopefully we know that when we're doing the photoelectric effect, we're talking about the energy going in and the energy coming out. It's an energy balance. We have the energy in, E, which is the energy of our photons, is equal to phi, the work function, plus EK. I'm being a bit vague here. This should be EK max. It's the maximum kinetic energy of any electrons or the photoelectrons that are being emitted by the surface. We're then going to remember that that is related to F, the frequency of our photons, which is on the x-axis here, via HF equal phi plus EK. We notice we've got EK on the y-axis, so we're going to rearrange, and I've put some colours in as usual so we can compare. We've got EK on the y-axis, we've got F on the x-axis, and we've got H and phi. What that means then, if we compare it to a straight line equation, which is what we get, we're going to have Y absolutely on the y-axis, EK on the y-axis, F on the x-axis, and then M equal to H, and then we've got this here. What this means is that these two lines should have the same gradient. Now, does that look right? Absolutely. H is the gradient of each line. You can see these two lines have got the same gradient. So whenever you're drawing these, you're going to expect the same gradient. There's a very similar problem that I've seen in another question paper, which shows lines of different gradient. If the gradient changes, then something has gone wrong. The gradient is equal to H. What must change, however, is the y-intercept. And because we can see there are two lines, if we extrapolate them out, whilst parallel, have different y-intercepts. Now the y-intercept is going to be governed by the value of minus phi. In other words, if you have a larger work function, then you are going to have a deeper well, if you like, out from which to climb out. And what this basically means then is that our surface y has got a greater work function, y, because the y-intercept, I've said the word y far too many times there, the y-intercept is much smaller, it's further down, it's more negative, and therefore it's harder to remove the photoelectrons from the surface of that material, aka it has a higher work function.